If you want to smile and learn, watch this video. But first, can you guess what this video is all about? Yes, that's right. We are learning about rocks in this video.
Rocks are all around us. You see rocks all the time. And some rocks are huge like the rocks that make up this massive rock formation. They're huge, but then sometimes rocks can be really tiny. Rocks are amazing. They're all around us. Alright, so what are rocks? Mm, yes, that's right. Rocks, a solid aggregate of one or more minerals. Now, most rocks are mixtures of multiple minerals like these rocks. Other rocks are made up of just one mineral, like in this picture. This is a picture of chalk. Chalk is a type of rock made of mineral called calcite. The next time you play with chalk, just think, wow, this is made of calcite. These are like sticks of calcite. Chalk is a rock that made of calcite. So, rocks are solid chalks of one or more minerals and they are super fun to learn about. That's why geologists are so cool. Geologists are rocks experts. They study rocks as their job. Geologists disagree about how many different types of rock they are. We can all agree on this. There are so many different types of rocks. To make things more simple, rocks are put into. Once a rock is formed, does it stay the same rock forever? No, because rocks are continually changed by many processes such as weathering, erosion, compaction, cementation, melting, and cooling. So, rocks are divided into three groups based on how they were formed, which is igneous rocks, sedimentary rocks, and metamorphic rocks. So, first is the igneous rocks or the magmatic rock. So, it comes from the Latin word ignis, which means fire and form when hot molten rock crystallizes and solidifies. That is why the parent material of igneous rock is magma. It is molten material from deep within the earth that cools and hardens. So scientists use the term magma for molten rock that is underground and lava for molten rock that breaks through the earth's surface. So, in giving names in igneous rocks, so it is based from texture. When I say texture, it is how big the crystals are, or it is also the overall appearance of rock sample. And next is a base from its composition. Next is the type of igneous rocks. So mainly we have two types of igneous rocks, and those are intrusive and extrusive. So they say intrusive, it is also called as platonic. So it pulls slowly beneath the Earth's surface and are created by magma. So the intrusive igneous rocks have very large crystals, or what we call the horseprint rocks. Next is the extrusive rocks, and it's also called as volcanic rock. So, when magma erupts onto the Earth's surface, or what we call the lava, it cools quickly with a very small or no crystals form. So, based from its definition, extrusive rocks forms when magma makes its way to Earth's surface as lava and then cools, so the crystals are very small, or the fine-grained rocks since the cooling process is fast. The composition of igneous rocks, and the first is felsic. So, felsic are light-colored rocks that are rich in elements such as aluminum, potassium, silicon, and sodium. Next one is mafic. Mafic or dark-colored rocks that are rich in calcium, iron, and magnesium. And poor in silicon another is the intermediate. It is between mafic and felsic. And last is for ultramafic that has very dark in color. Next is the texture. So when you say texture, it is overall appearance of rock. So we have here the word aphanetic. So when they say aphanetic, those are the fine-grained rocks where it cools quickly with little to no crystalline form through rapid cooling at the surface of the earth. Second one is the phaneretic or the coarse-grained rocks where it takes longer to cool, so giving mineral crystals more time to grow, and it is formed far below the surface of the earth. Third one is the porphyritic. So with large crystal with small crystals, we also have the glassy order, solid from rapid quenching. And last, we have the proclastics. Those are the composite of ejected fragments. So we have here four different samples of rocks. And let's identify the classification of the following rocks. So we have the granite, rhyolite, gabbro, and basalt. It's what we call the felsic rock, or they are light in color. And for gabbro and basalt, those are mafic rocks or dark in color. Next, we have the coarse grain for granite and gabbro. And for rhyolite and basalt, or fine grain or the phanetic where it cools quickly. So we are here another example, which is obsidian. And let us also identify the type classification of this rock. So obsidian is a dark colored volcanic glass that forms the very rapid cooling of molten rock material. So it cools so rapidly that crystals do not form. And let us identify if this rock is felsic or mafic. Is it fine grain or coarse grain? And is this rock intrusive or extrusive? Yes, that's right. So, based from its characteristic and appearance, we can say that obsidian is a mafic. Fine grain or coal as a phanetic, where it cools quickly with little to no crystal in form through rapid cooling at the surface of the earth. And it is extrusive rock. Let us proceed to the other type of rock, which is sedimentary rocks. So, these rocks provide information about surface conditions that existed in the earth past. So, sedimentary rock are particles of sand, shells, pebbles, and other fragments of materials, called sediments, accumulate in layers and over a long period of time hardened into rocks. So, these rocks are forming from lithification. So, lithification is a process cementing soft and consolidated sediments into hard rocks. And sedimentary rocks are formed at or near the Earth's surface, and the layers of rocks is what we call strata. And stratification is the process in which sedimentary rocks are arranged in layers. Next, we have the types of sedimentary rock. Mainly, there are three types of sedimentary rocks. Those are the clastic, chemical, and organic or bioclastic of sedimentary rocks. Let's start with the clastic first. It is formed from the accumulation of clast. So, let's start with the clastic first. It is formed from the accumulation of clastic. So, clastic are little pieces of broken rocks and shell, or it simply involves breakdown of rocks into smaller ones at the surface of the crust accumulate as clastic, filled on the top of other and liquefying. So, we have here sample of clastic, which is breccia. And another example are conglomerates, sandstone, and shell. Breccia is the term most often used for clastic sedimentary rocks. that are composed of large angular fragments. The spaces between the large angular fragments can be filled with a matrix of smaller particles or a mineral cement that binds the rock together. And next type is the chemical sedimentary rock. So, formed when dissolved materials precipitate. So, this type of sedimentary rock form when the salt minerally precipitate from a solution. So, we have here sample which is the limestone. So, it is a sedimentary rock composed primarily of calcium carbonate in the form of the mineral calcite, and it most commonly forms in clear, warm, shallow marine water. So, it is usually an organic sediment rock that forms from the accumulation of shell, coral, algal, and fecal debris. And the third one is the organic or bioclastics sedimentary. So those are the remains or plants and animals. So these rocks are formed from the accumulation of animal debris or the remains of plants and animals. So the best example for the organic sedimentary rock that forms from the accumulation and preservation of plant materials usually in a swamp environment. So coal is a combustible rock, and along with oil and natural gas, it is one of the three most important fossil fuels. So, last type of rocks is the metamorphic rocks. Comes from the words meta, which means change, and for or metamorphic means a change in form or a change in shape. It is also changes metamorphic with temperature and pressure, but remains solid and last metamorphic rocks usually takes place deep in the earth. So this type of rocks forms from the pre-existing rocks, either metamorphic, igneous, or sedimentary. Examples are quartzite, marble slate, or the phyllene. Next, we have the types of metaphorism. So we have here the compact, the vaginal metaphorism. So let's start with contact. So from the word itself, contact, so this kind of rocks is heat by nearby magma. So increased temperature change the composition of the rock minerals are changed into the new minerals. So the best example for contact metaphorism is the hornfield. So it is a fine grained non-folated metamorphic rocks. Next is the original metaphorism. So the pressure builds up in a rock that is deep within the earth. So large pieces of earth crust collide and the rocks is deformed and chemically changes by heat and pressure. So after identifying the two types of metaphorism, let us proceed to the classification of metamorphic rocks. So first we have the texture. So it refers to the size, arrangement, and grains within the rocks. Another is the foliation. These are any planar arrangements of mineral grains or structural features within the rocks. We have here foliated and non-foliated. So in foliated metamorphic rocks, it contains aligned grains of black minerals, while non-foliated metamorphic rocks, the mineral grains are not arranged in a planes or bands.
That's all. Thank you for watching. I hope you learned a lot from this video. Bye!